Hello, today we're going to learn how to create a minimal RBD sim in Houdini to create an effect like this. So let's jump into Houdini. So here we have the setup from a few lessons ago when we created a signed distance field. And you remember we could visualize this using a volume convert, a convert volume. So this would take the signed distance field and create a geometry like this. But for now we are going to start with just the signed distance field. And let's move this up above the ground plane by pressing Tab and type transform. And then connect this after the signed distance field and move it up 1 meter in the y-axis. And next add a null and connect this after the transform and call this geo. And this is what we will pass into our RBD simulation. So next let's press Tab and type DOP Net, or rather DOP Network, and connect the geometry to the first input and call this RBD sim. And let's go into the RBD simulation and clear all the nodes so we have an empty canvas to work with. Okay, so first of all we need to bring in this object into the simulation. So press Tab and type empty and select the empty object and call this just object and press P and rename this to $OS. And then if you go to the geometry spreadsheet, then you can see we have an empty object here. So let's continue and bring in the geometry into this object. So press Tab and type SOP Geometry and connect the object to the first input and rename this to Object Geo. And then select this and press P and under SOP path type backtick and op input path. And then go up 1 level with dot dot and input number 0 and another backtick. And now you can see that we have a geometry added to our object. And if you click the geometry, we can see that we have our density field here. So this looks good so far. So let's now try to simulate this. And of course, just simulating this wouldn't do anything without some kind of gravity. So let's add a gravity first. So press Tab and type gravity force and connect this after the geometry and just call this gravity. And if you look at this, you can see it's called forces gravity. You could also change this to forces $OS so we get our own name, but it has to be inside of forces. And let's untick unique data name. So now we have a gravity under the forces group. And it's important that we use this group, otherwise the RBD solver will not be able to find this force. So next let's add the solver. So press Tab and type RBD Solver and connect our object chain to the first input and rename this to, for example, solver. And then select this and press P, and we don't need to make the object mutual effectors, so you can untick this one. So now we have a minimal setup with just an object and some gravity. So let's try this. So go to the scene view and open the timeline and press play, and you can see it falls down. So next we want a ground plane that it can collide with. So let's press Tab and empty object again And let's call this object ground. And as usual, press P and change the object name to $OS. And let's then add a merge node. So press tab and type merge. And this is a special node that will create relationships between two objects. So I connect my ground object on the left and the solved moving object on the right. And I will call this collision, so we know what we are doing. And then select this and press P. And you can see here it says left input affect right inputs. And the relationship is a collide relationship. And you can also see in the geometry spreadsheet, if you look under the object, then we have the relations in group is the collision. And if you look under the ground, then the relations in affectors is the collision. So the ground affects the object, but not the other way around. And we don't need the object to move the ground, we only need the ground to stop the object from falling. So far so good, but this is just an empty object, so of course it will not do anything yet without a collider. So let's add a collider to this. Or actually we also need a geometry even if it is empty. So let's press tab and SOP Geometry and connect this after the ground, and let's call this ground geo in the same way we did with our object. So let's just put them side by side to make it easy to understand. So next we will need, so let's press P here, and we don't have any geometry, but we need a collider. So let's press tab and type SDF for signed distance field and select SDF Representation and connect this to the ground geometry and call this ground SDF. And select this, and for the mode you can select implicit plane. So this will create a plane collider. So we don't have any geometry, but we have a collider, so it will work. So let's look in the scene view and press play, and you can see it stopped. So it was resting on the ground. So let's look in the geometry spreadsheet, and you can see that we have a volume and a sphere tree, and these are both used for collisions. And under the ground we also have under the geometry a sphere tree and a volume. But we could also be explicit about the SDF for the object, so we could add an SDF here by pressing tab and SDF Representation and connect this and call this object SDF and press P and do a volume sample. And that's good. So let's try this. So now it is falling down. And this is a little bit boring movement. So let's change the transform and add some rotations. So maybe 5 degrees and 10 degrees for X and Y. And let's try now what happens. And now you can see it falls down in a more interesting way, but it is quite bouncy. So let's reduce the bounciness. So let's go back into the simulation, and for the ground plane press tab and type apply data. So here we can apply more data about the ground. And for the data, let's type physical parameters and connect this to the apply data and press P for the parameters and change the bounce to 0. And that will remove the bounce. So let's look at this result. So now we have a less bouncy simulation. A little bit boring perhaps, but let's go for this for now. So next we want to bring out something more interesting from this simulation. So for this we need a DOP import. So press tab and type DOP import and connect this to the sim and view this, and press P to edit, and for DOP network press backtick op input pass and a dot for this node and (0) for the first input and backtick again. And if you middle click, you can see this is going to the RBD sim. So that is the DOP that it will import the information from. And the object we want is the object. We don't want the ground. And we want to import, in this case, we will want to create points to represent objects. So it will not bring in the object itself, it will only bring in points that represents the movement and orientation of the objects. And then we can stamp the object onto these points. So let's create points. And this is only one point because we have only one object. And let's untick for now, and then we can tick back what we need. So let's do like this. And that looks good. Okay, so now we have here one single point. If you look in the, you can also see it in the viewport as tiny little dot. So here we have one point, and we don't need all this stuff. So let's look again. Well, let's keep it like this. Okay, so next we want the geometry to instance onto this point. And we want something more interesting than this SDF. So let's convert this SDF back to a volume. So let's create a volume VOP. So tab and volume VOP. And let's connect this after the transform. And let's go inside and delete these nodes. And let's add a snippet. And here we can say that at density, which is the name of this volume, equals if density is bigger than 0, then it will have the value 1, otherwise it will have the value 0, and export the bindings. So let's see what this will create. Let's go up and select this. So this turned the SDF back into a volume. And now we can stamp this volume onto the point we got from the simulation. So let's do a copy to points. So tab and type copy to points and connect this volume into the first input and the point into the second input. And now if we look at this result, then we have this volume. So let's now play this and see what we get. So there is still something wrong. So go back to the DOP import and press P. And let's see what we need to make this work. So we want to transform the geometry with position data. So let's tick this one. And let's try this. And this is still not. So let's see. Transform geometry with geometry data. Let's try that one and see. Okay, this doesn't work either. Let's try trigger the simulation. Okay, this is not quite yet. So let's remove the transform and let's try this. Okay, so this is a little bit broken, so let's see. Let's untick this one. Okay, that won't do anything. So let's create points to represent objects and transform geometry with position data. Let's try this one. Okay. Let's go back into the simulation and look at this SOP Geometry node here and see if there is something we are missing. So, primitive group. If we look here, then this looks fine. Import. Object geometry data pass, use single object. Center at pivot. Okay, let's try all this. Okay. So let's see which one we actually needed. So let's uncheck one at a time here. And okay, so we need to have the center at the pivot, and let's try without the others. Okay. So here we have the result. So the correct settings to stamp your geometry in this case is to transform geometry with position data and center at pivot. And then we will have this result. So I hope this was helpful, and see you next time. Over and out.